Hello dear friends, welcome back on a tutorial from the CAD from the NX. So today we will see the CAM tutorial, and this is the final product. And today we will see how to use the groove operation and the pocket milling in the NX. So we have the two types of the groove here. So the linear groove and the circular groove. So we will learn basically how to use these two type of the grooves in the NX software, and we'll just remind how to use the pocket milling. So this is our the part model environment. So for the beginning we will go to the manufacturing environment in order to do this. Select here the application, and here select the manufacturing as usual. So the manufacturing, the environment is opened here with the menus in the toolbar here in the top bar, and here from the navigator we can switch over to the operation navigator here. So as usual, for the beginning we have to define our the workpiece and the 0 point and so on. In order to do this, from here select the geometry view. Now it's selected in my case, and here double click to the workpiece, and here specify the part, and select this icon, and select the workpiece here. Just press OK, and select here specify the blank, select this one, and select here from the type, let's make it boundary block. You see the blank boundary block is created here, and let's in this case let's make the boundary block all the direction along the x, y, and z and 0. Let's keep like this. Press OK. So we defined our workpiece and our the blank geometry. We can see here. Let's pressing display. You see that it's the workpiece, and this is our the blank geometry. And just press OK. Now here we have to define the 0 point of our workpiece. So just double click here this one, and here you see the dynamic coordinate system is generated here, and you can put your 0 point at any point. So in this case I will put here in the corner. You can just put here, you see the changing. I will put in this position. This is our the reference 0 point, and press OK here to define this 0 point. So we defined our initial conditions. Now let's go on with the operation. So let's analyze the workpiece. So we have the two grooves here. You see the linear groove, and here we have the circular groove. Also, we can here obtain this one using the pocket milling. So for the beginning, let's create the tool that is the feeds on these grooves. Let's measure some points here. Go to the analysis, simple distance, and let's measure the distance from here to here. It's a 10 millimeter, and here to here is a 10 millimeter here also. Again, let's measure this distance, the simple distance from the here to here. Let's measure the surfaces. So simple distance, select the simple distance, select this face, and select the upper face here. Let's zoom it here, and maybe we can select this edge. So this is again 10 millimeters. So, and let's measure again this distance for the pocket milling. The surface between this one and this one is a 20 millimeters. So we defined the geometries distances. Now we can create for the beginning the tools for the pocket milling and for the grooves. So go to here the home, select here the create tool, and for the pocket milling we will use just the end mill. So in the type the plain milling, the mill, end mill with the flat, and just here you can define its name. Let's make it the diameter 10 millimeter. That's okay. And here specify the diameter of the tool is a 10 millimeter, so it is for the pocket. You can define here the material as usual. Now it's okay. You can define the shank folder. So in this case, I will skip this point. Just press OK. So if you go here, the tool manager here, the machine tool view, you see this tool is created, the end mill with the diameter of 10 millimeter. Now, again, let's to create the tool. In this case, we will create this T cutter tool for the grooves, the linear groove and the circular groove. Select this one and just here specify the name. Press OK. You see the tool is created here. Now you can here define it is the values. So the neck diameter, and what is the important is this one is the length, this one. In this case, in our case is the 10. The gross distance, so that minimum should be the 10. You can here the lower than the 10 millimeter, but the minimum should be the 10, not higher than 10 millimeter. Here it is important. And let's define that this diameter also a little bit bigger. This one, you see the diameter. Now this is our tool, and we can make it higher. The length, let's make it 60 millimeter, the length of this folder. So because it should be the remove this material and not to touch. And this one, we can make it higher, longer. So in order to be the safe position, so just press OK to accept the tool. So we have created the two tools here, this one and this one. Now we will go with the operation. So for the beginning, we will remove the pocket here. So here go to the create operation, and here from the type the mill planner, and here select the floor and wall for the obtaining the floor operation, this pocket milling. And from the location located inside the program, the tool, select the end mill, this one diameter 10 millimeter. So geometry, it should be the workpiece, and let's make it the method as the finishing operation. Here you can specify the name, so you can write any name. Now I will keep here the floor and wall. Just press OK. Now we will the forward to this menu to specify the floor, the geometries. In order to do this, select here the specify the cut area is important. Just press this one and select this face to remove the area here. So it is the space one is selected here. Press OK. So here you see the floor is cut area is white, and you can here just activate this one, automate the walls. So you see the walls will be, if you display this one, you see the walls will be automatically selected here. So here it should be the workpiece, so it defines the workpiece itself automatically. Let's check the tool and the tool axis. So along the Z axis it should be the positive, and the method is the finishing. And here the cut pattern, that's the make it start. If you select from the follow periphery, it will start from the center. So let's do this one. And here what is the important, that's the floor, the blank thickness distance, which was the 20 millimeter, which we measure the distance of this pocket. And the depth per cut, let's make it 2 millimeter. It depends on the tool specification. So it means that it will remove the every 2 millimeter material from the starting the upper surface. So you see here the layers, it will be the 10 because the 20 divided by the 2 is 10, so 10 layers. So we specified our operations here, and just here press the generate to see the tool path. You see the tool path is created here to remove the pocket, and we can go to the verify option and to see here the result. Select here on the 3D dynamic, and you can specify the animation speed and just press the play to see the results to obtain the pocket. You see that the pocket is started to remove every 2 millimeters the layer. You can speed up your operation to see the final result. You see the material, the under the part is the remaining because we are not able to remove the material in this part using the floor wall and using this tool. So because it is not possible to reach under these positions. So in this case, we will use here the groove milling. So just press OK here and press OK again. So we will use the groove milling, and general is we will use the radial groove milling, the operation. So in this case, the create operation again here, and you can find the radial groove mill operation inside of the type of here the hole making. And here we have you see the radial groove milling operation. So select here the radial groove milling, the location, select program. The tool is this tool. We will select which we created the geometry workpiece, and method. Let's make it finishing operation and press OK. Now we have to specify the groove. In order to specify the groove feature, we have to select here this icon, select the groove feature, and here in the groove you will automatically that you have to select here the object. In this case, this is you see the counter red. So you see the groove is selected here, the feature. And what is important, you see here you see the groove dimensions and all the parameters will be taken from this geometry. You see the depth, the start diameter, the final diameter of the groove, and here in the list you will see this parameters also, the diameter, the start diameter, the depths which we select, which we measured. So you see all the parameters will be coming from the model of the model directly. So it is selected now. You can press OK here, and you can check the tool is correct, is selected. What we can do here. Here we can define it's the level sequencing. So here the several options, that is the starting from the ceiling to the floor, or you can make from the floor to the ceiling, or you can start from the center to the floor, or vice versa, and so on. You can check, you can select several options. So in this case, since the depth of our groove is 10 millimeter, and the tool, the height is also the 10 millimeter, so it is not important in this case. It's just only the fits in the one pass. So we can start from the ceiling to the floor and just generate it here to see the result, the tool pass. So let me go back to this one. So here we have to change the diameter of the tool from the 50 to the 60. Here I change it here because there is some collisions. So press OK, and let's generate the toolpath. You see the circular, the toolpath is created for the groove milling for the circular feature, and go to the verify option, and let's decrease the animation speed and just press play to see the result. See the toolpath is created, and let's reset it, and let's decrease it again, and let's generate again here. You see the circular, the groove is obtained, and we removed all the material in the lower part in the both side. You can check here. So this is how to use the circular groove operation. Now you see in the operation navigator we have the two operations. Which one? The first one is the floor operation, is for the pocket, and the radial groove, that this operation. Now we will continue. So we will obtain now this the linear groove. So we will use the same tool here, that this cutter, but in this case we will use the different operation. It is a linear groove operation. So let's for the beginning create the operation. Here the linear groove operation is located inside of the subtype of the mill planer. So select here the mill planer, and we will see here is the groove milling. For the linear groove milling, select this option. The usual location inside of the program. So to the cutter, the workspace geometry, and let's make a finishing operation. Just press OK. So in this case also you have to, for the beginning, select the groove feature. So this is our the groove feature. In order to select specify the groove feature, we will use these options. Specify the groove feature, select this one, and here select the object. You have to select this groove feature. You see groove feature is selected. The same way it defines the dimensions of the groove from the model, with the lengths, with the depths and widths, you see, and you can see all the parameters here. So it will be directly defines the features of the groove from the model which we created, and just press OK. So you see here is selected our groove, and you can see here by specifying this icon. So our the groove is selected. So the tool is this one. So the operation is the finishing. Let's make it 2 pass. And what is the important here? The cut level. Select here the cut level inside. And the same way you can define the cut level. There's different options. That's the starting from the ceiling to the floor, the starting from the floor to the ceiling, or you can start from the center, and so on. So you can define any option. So in this case I will select ceiling to the floor. However, it will be just one pass, since this distance is the same as the distance of the tool, so 10 millimeters. So it will be just one pass along in the vertical direction. However, it will be here the 2 pass along the horizontal direction, because here the 2. We will see this one also. Now let's generate the tool operation, the tool pass. You see the tool operation, that is the 2 passes generated. 2 passes, you see, along the horizontal direction, and only the 1 pass along the vertical direction, since we have the same the depth of the groove with the 2. Now let's verify it. So you can let's see here and just play it. So you see the 1 pass and 2 passes along the horizontal direction. If we change this one to the 1 and make it generate again here, we will have only the 1 pass. You see only the 1 line along the horizontal direction. So verify it. Only the one pass, that's enough. So you can define the number of the passes by yourself, and it depends on the tool specification. For example, we can change here the number of the levels on the vertical direction if we have the different tool. Let me show this one also. Let's edit to some parameters, and let's make it here not a 10. Let's make it 2. This tool, you see, I will show here, you see the fluid length becomes 2 millimeter, and press OK here. Okay, now let's check the groove. So in this case, you see the number of the layers, you see the number of the layers becomes the here the number of the layers you saw. It starts from the ceiling and until the floor. So every 2 millimeter will remove the 2 millimeter, since our tool is the 2 millimeter. So generate it, and here verify it. So in this case, so it starts from the floor, from the ceiling to the floor. So the plate. So I will change it here. Now let's for the beginning make it these two operations, the generator tool pass, this one and this one, generate a tool pass, because we changed our tool. Okay, now let's go to this final, the groove, the linear groove again, to see the results. So the cut level, let's check the cut level. Start from the ceiling to the floor. Okay, so generate it again to be sure. So cut level is generated here. Okay, let's make it 1 for the beginning. So verify it, and that's this one. See, it starts from the ceiling every 2 millimeter cutting, because the tool is the 2 millimeter. So it starts from the ceiling to the floor. Because why start from the ceiling? Because we started the selected cut level. Here, let's will show it. Because we selected here in the cut level, starting from the ceiling. If you select from the floor to the ceiling, so press OK. Okay, and generate it. So double click here. So in this case, we started the operation from the floor, and let's see the result. Verify it. Let me move it like this to see the better position, and press play. You see, in this case, it starts from the floor and ends in the ceiling, in the top position. So you can by yourself define the tool path like this in the linear groove like this. So this is the how to obtain the linear groove in general. So okay here. So this is the tutorial for today. So we started with the pocket milling, floor and wall. We made the radial, the groove milling, and we made the final is the linear groove. So and we made some optimization in the tool path, how to optimize the tool path and so on. So you can define by yourself this tutorial, and thank you very much.